Now, when we talk about critical values, let's go ahead and take a look at a rocket ship example. You know, rocket ships are pretty cool, right? And so let's think about, we got our rocket ship here, and it's going to go on a trip into space. And so there's the Earth's atmosphere, right? And so what we're going to talk about is the fact that on this trip, it's going to travel and it's going to be below the Earth's atmosphere until that one point where it is exactly equal to the Earth's atmosphere. Okay? That is our critical value. Okay? The rocket ship is the exact same altitude as the Earth's atmosphere. And why that's important is because if it's equal to it at that point, then we can look before that time. And before it, it's less than the Earth's atmosphere. And after it, it is more than the Earth's atmosphere. So these critical values, okay, tend to be points of change. They're important. So we're going to look for those critical values, okay, because if we can find the critical values, then we can just look to the left, to the right, in between them, and we can then test, okay, before and after or in between, and try to figure out if the relationship changes at those moments. So let's look at this inequality, and let's break it up and look at it graphically. So we're going to make the left side of the expression equal to y1 and the right side equal to y2. And so if that's the case, then what we really want to know is when y1 is greater than y2. Now, since we're comparing y's, let's go ahead and talk about the fact that an x value is referring to our horizontal axis and y is referring to our vertical axis. So we want to know when the red graph is above the blue graph. Okay? Well, if we're going to look and see when they're different, let's look and see when they're the same and find that critical point. The critical point is when they're equal to each other. Okay? And what we really want to know is what x values make them equal to each other. X equals 3 does. So if we know that these two expressions are the same at x equals 3, then that means that they are different, okay, or unequal whenever x is greater than 3 or less than 3. Basically when x is not equal to 3. So all we need to do is test those x values, those x intervals, and determine if it works in those intervals, okay? And we have x is greater than 3 and x is less than 3. So we just pick a value that satisfies those conditions, and those will be our test values. So for example, x equals 5 or x equals 0 for the two different intervals. And then we just substitute in and test them out, okay? And if the inequality is true, then we know that that is the interval that we're looking for. So when x is greater than 3, it works. And if you notice, if we go to the right of x equals 3, our red graph is above the blue graph, okay? But if we test x equals 0, so that interval x is less than 3, what we end up with is -1 is greater than 5. Well, that's clearly not true. And if you notice, the red graph is below the blue graph when x is equal to 0 or is x is less than 3, not satisfying our expression.